These are a few properties that we are going to see now. Salts are usually solids at room temperature. Being solids at room temperature means that they should have high melting points. A salt has got an acidic radical and a basic radical, and therefore it is ionic and therefore has high melting point and will be in the solid state usually. And most of them are water soluble. There are many exceptions to this. For example, we can take lead sulfate, we can have barium sulfate, we can have lead sulfide, we can have copper sulfide, we can have silver chloride, silver bromide, silver iodide. So like this we have a variety of salts which are water insoluble. If you take for example nitrates, all nitrates are soluble. All salts derived from sodium are water soluble. For example, Na2S. What all we found are insoluble in lead or even silver. Lead chloride is also insoluble, PbCl2. But all those things are soluble for Na2S. That is, all Na plus salts are water soluble. For example, NaCl. We said Na2SO4. All are water soluble. So as a rule, we can say that nitrates and sodium containing salts are water soluble. Remaining, it is variable. Then conducting electricity, if the salt is dissolved, means has already dissolved in aqueous solution, then it is going to be conducting. It is conducting electricity because it gives out ions, and these ions are going to conduct the electricity. So ion movement happens in aqueous solution, and this is what is making it conducting in the aqueous solution, electrically conducting in the aqueous solution. Then some salts can be hydrated. For example, we have seen copper sulfate 5H2O. We can have zinc sulfate 7H2O. We can have ferrous sulfate 7H2O. This is called blue vitriol. This is white vitriol, and this is green vitriol. And this one MgSO4 7H2O. This is Epsom salt. These are all in the solid form. This water is part of the crystal. It is not going to make them liquid. Copper sulfate 5H2O is a solid. Similarly, MgSO4 7H2O is a solid. Similarly, this one. Gypsum, that is dihydrate, or you can have the same thing in this form. This is plaster of Paris. We use plaster of Paris to make the molds, and that turns into gypsum. So the set form is gypsum and the powdered form is plaster of Paris. So like this we have salts which are also hydrated. Some hydrated salts can lose water upon heating. Not all. Usually it is the case, but not always. Some salts can lose water even on exposure to air. So such salts are efflorescent. So efflorescent salts are going to lose water by simple exposure to air. For example, you may have Na2CO3 10H2O losing 9 moles or 9 H2O units by simply putting it in air. The remaining H2O upon heating will come out. So efflorescence is a natural tendency of losing water by exposure to air, that is to the environment, whereas heating part can also lose water molecule. For example, copper sulfate upon heating will turn into CuSO4, which is anhydrous. So anhydrous means not having any water molecule attached, and this anhydrous part is white in color, or we can also say colorless, and copper sulfate is blue, which is pentahydrate. So 5 H2Os are making it blue in color, whereas no H2O will make it white. So there are some substances which on heating will lose the water of crystallization. Some can lose simply by exposing them to air, and a few can also turn into liquid by absorbing moisture or may absorb moisture. For example, absorbing moisture is hygroscopic. The tendency to absorb moisture is hygroscopic, but if it remains in the solid form, it is only hygroscopic. But if it turns into liquid, that is dissolves in the moisture absorbed, then it is deliquescent. So salts interacting with water can be simply hydrated, remaining in the solid, or may lose water molecules by exposure to air, or on heating, or may absorb moisture, and turn into liquid. So different cases we have in salts. So salt on treatment with water or salt in association with water can be either a hydrated salt which is losing H2O on exposure to air, or on heating, or a salt which is going to absorb moisture from the air and still remaining as solid, or absorbing moisture and turning into liquid. So different varieties of salt and its interaction with water we are going to see now. The simple hydrated we have already seen, copper sulfate 5H2O, that is blue vitriol. Efflorescence will happen through the decahydrate losing 9 units of water and becoming a monohydrate, and that monohydrate on heating will turn into anhydrous. Anhydrous part, we can simply heat this pentahydrate and then get the anhydrous part. And hygroscopic, absorbing the moisture but not turning into liquid, calcium oxide or cobalt chloride, they will simply absorb the moisture and still remain in the solid form. Whereas deliquescent is going to turn into liquid, means will get wet. For example, calcium chloride, magnesium chloride will turn into liquid. So that way we have salt and its association with water in different ways. When a salt is dissolved, we will find that at a particular temperature, the maximum amount of salt that can enter a particular volume of solution is a fixed value. Let us say that x grams, or let us say 10 grams are going to dissolve in 100 ml of the solution. Means 10 is the maximum. If I put 10.1, what is going to happen to that 0.1? That 0.1 will not dissolve. That 0.1 will come to the bottom as a precipitate, means it will be in the undissolved part. That is, if I have a beaker and I have added say 10.1 gram, that 0.1 gram is going to be here at the bottom as a solid. So what is the maximum that this solution is able to take? Only 10. If you have less than 10 grams, let us say, then we can still add some more amount of salt and still expect the salt to undergo dissolution. That solution is called an unsaturated solution. An unsaturated solution is one in which the salt content is less than the maximum that the solution can take. So unsaturated solution can still take some amount of salt and dissolve the salt. That is an unsaturated solution. What is a saturated solution? Which contains exactly equal to 10. Means you have reached saturation. Means it is not going to take up any more grams of the salt. Then what is supersaturated? Supersaturated should be this then, more than 10 grams, more than 10 grams in the dissolved condition. Now how is that extra going to be dissolved is an experimental technique. So how to get more than 10 grams entering into aqueous solution is an experimental technique. The usual thing that happens is a particular value, that is 10 grams. So if you are able to dissolve even that extra grams that you have added, then that solution is supersaturated. A supersaturated solution is one which contains more solute than expected. That is, it is going to have more grams of the salt than the saturated solution can have. So that way a supersaturated solution is not a normal solution, because a normal solution will have only 10 grams, which is experimentally found. But with some technique, we are able to dissolve more grams in the solvent. and this becomes a supersaturated solution. Supersaturated solutions, as I said, are not stable. With a small amount of disturbance, either in the form of adding a crystal or giving a jerk and giving a disturbance to the system, we are able to make supersaturated turn into saturated. So supersaturated solutions are not stable, but they can be made and they will rest for good amount of time if we have particular technique employed.